everyone. The next experiment is the induction motor. Our induction motor board includes the main board that has a stator on it. The stator has three windings. In lab soft, the windings are to referred as to copper windings on the top, the red windings, the one at the bottom, and the green windings, the one on the actually left. So you might see it in a different way on the board, but that's the windings for the stator. For the first experiment, which is the rotation and magnetic field, we have our rotor as a permanent magnet, and then we have three windings here on the board. These windings could be connected as delta or a star. Depends on the jumpers that we put here. If we put the jumpers here the way that we are putting vertical, then all the windings are going to be connected from one end, and that makes it a star connection. In this experiment, we are connecting one side all together, one side of the windings together on the board using the jumper, and the other sides are connected to three relays. And the other side of the relays, the common side, are connected to the ground and 15 volt. So what happens depends if the relay is connected to the ground or connected to the 15 volt. One end of the windings, the copper or the green or the red windings, could be connected to ground or to positive 15 volt. For example, you see here the animation at the top that it shows that the relays, for example, relay 1 on the top, now is connected to 15 volt, meaning that the U winding is powered. If it switches to the ground, then the U winding is not powered. Same for the relay number 2 and relay number 3 that are used to apply the power to the V windings or W windings. And again, the other side of the windings is connected together in one common point to make a star connection. How do we switches these relays? By clicking on one of these pages. So if you click on magnetic field 1, then this would be the configuration for the relays. You can see that the relay 1 is connecting the U windings to the plus 15, meaning that it's powered, but relay 2 and relay 3 are connecting V and W windings to the ground, so they're not powered. So when this happens, you should let us know that what is the position of the permanent magnet if only U winding is connected. And it says what happens here. What you need to type here in this box or on your lab manual to let us know where the red one is pointing to. For example, if the red end on the permanent magnet is pointing at 2 o'clock, say it is 2 o'clock. If it is pointing at 5 o'clock, say it's 5 o'clock. So I already click on magnetic field 1, and you can see the position of the red pole on the magnet. Now I'm going to click on magnetic field 2, and you saw that the status of the red pole changed. So let us know what time it's referring to. For this one, U and V are powered, and W is not powered. Then next one, next one only V powered. Magnetic field 4, V and W powered. Magnetic field 5, this one the only W is powered, and I'm assuming that you guys are watching on the part that is showing what happens to the permanent magnet. And the last one, U is powered and W is powered, and you saw that again the location, the position of the red pole changed. So you let us know exactly what time it's the North Pole pointing at, 2 o'clock, 4 o'clock, or whatever, as I explained. So that's it for this experiment. Next experiment is rotation with three-phase current. So for this experiment, what we did, we put all the jumpers on the board. So the three jumpers in below, they are creating the star connection because they're connecting all the windings together from one end. And the other sides of the jumpers on the top are connecting the other side of the winding to the three-phase power supply. So the moment that I click on the setting for the power supply, which is 6 volt and 1 hertz, you will see that the magnet started rotating, and we want you guys to observe the experiment and rotation of magnet and answer the questions for this experiment. I stopped the experiment here and we go to the next experiment. So next experiment is about measurements in delta and star configuration. For this experiment, we are using a squirrel cage rotor. This is the structure of a squirrel cage rotor. You can see the conductive bars, and I'm sure that you have been lectured about the like a structure and the way a squirrel cage rotor is working. So I'm going to put it back. I also put a marker with the highlighter, a line marker, so that when it starts rotating, you can see it. Otherwise, the video is not able to differentiate between, a stalled rotor or a rotating rotor. So I put that line. You can take a look and make sure right before I apply the power to see if it is rotating or not. Then I have a few jumpers here. If I put the jumpers vertical, then it would be a star connection. I already explained it to you, but we want more explanation and a diagram on the lab manual to explain this. And what I'm doing on the top, the other side of the windings are connected to the power supply if I put these jumpers. Again, you have to refer to the diagram on the lab manuals and the diagram from the board to explain why this makes a star connection. You see that I'm missing a jumper here. The reason is that I removed the jumper to be able to connect these 2 points to the resistor board on the top and to measure the current going through the green winding. And this the resistor board is connected to the channel B. So channel B on this experiment is measuring the current going to the green winding. Also, I have a green and blue wire connected across the windings, the green windings, that goes to channel A. So channel A is measuring the voltage across the green windings. So the multimeters are shown here. On the top, we have multimeter, the voltmeter A. I'm going to set it to AC volt. And the bottom one is the current meter B. And I set the 1 ohm. So you have to make sure this one is set to 1 ohm. By default, is coming as 10 ohm. I'm going to take a look at the rotor and pay attention to the blue line marker on the rotor. I'm going to apply the voltage, and you can see that the rotor is started rotating, and the voltage and current could be measured using the voltmeters and current meter. Now I'm going to stop and switch to the switch to the delta. For delta, the horizontal one is going to go like the vertical jumpers are going to go horizontal. So this vertical becomes horizontal, and this one, these 2 wires acted as like a jumper because they're going to the 1 ohm resistor. This is also going to be horizontal. Everything else is going to remain the same. Now we have the connection in delta, and again we want on your lab manual, lab report, to explain why we could just use, how we could use this jumper to switch from horizontal to vertical. I'm going to apply the voltage again, and you saw that the rotor started rotating, and the new voltage and current are shown on the voltmeter. Next experiment is measurement on the stator. So what we do, we only connect one of the windings, which is the green windings. We connect it to the V2 voltage on the power supply. And the other one is connected through a jumper to L1. So basically the green winding is powered by V2 and V1. So three phases, only two phases connected across the green windings. So we don't expect to see any rotation, but we want to do some measurements. So the lab volt is asking to change the voltage until you read measurement of 6 volt on voltmeter A. So I'm going to start from 6 volt here, and I see only 4 volt on the multimeter A, so I'm going to increase until I get 6 volt over there. And this is close to 6 volt, because if I go one step lower, probably I might get even lower. What I think 6.1. So maybe here it's still 6.1. Okay, here changed. I think if I set this to 9 volt, yeah, 8.8 is good. So the value of the current is questioned, so you have to read the current from the current meter B, which is the below one on the screen. I'm gonna disconnect the power, and the next experiment is asking to let's move this voltage here, close this one. I'm gonna voltage. So it's asking to open the three-phase power supply. It's asking to set it to different voltages and different currents. So let me move this back here and move this here. So there is a table. It's asking to set to 10 hertz and 6 volt. So I'm gonna say 6 volt here and 10 hertz. And I'm turning the power on, so I can see the over the range light is on. So I'm gonna increase the voltage. So now you can read the current from the bottom one and the voltage from top. Next one is asking to go to 20 hertz. So voltage stays the same, but it's only frequency. So now 7.4, again that one went on, so I'm going to increase the range. So 7.6 on the top, 0.34 bottom, going to 30 hertz. 7.7 on the top, 0.34 on the bottom, going to 40 hertz. 7.7 on the top, 0.33 on bottom, going to 50 hertz. 7.7, almost 7.8 on the top, and 0.33. Maybe we can just lower this one. It was better if we had lowered it. So 327 for the 50. Maybe I can go back to 40 to get a better reading. So 330, almost 2, let's say, for 40 hertz. For 30, 337, and for 20, let's say 346, and for 10, 350, let's say 51, I would say. Okay, this is the values that you need for the table. And next part, I think it's just calculation that you need to do. So that's it for this experiment. Next experiment is control characteristics of the asynchronous machine. In this experiment, we are going to operate the motor using the characteristic control feature on LabSoft, and the goal is to find out about the optimum voltage frequency
settings of the motor. So in this experiment, I have a motor control unit that you can set the frequency, you can set the ramp speed, and then also you can change the starting voltage simply by dragging up and down the point on the starting voltage using the mouse. You can change the starting voltage. And then in the table there is a column for voltage, there is a column the starting voltage, there is a column for frequency that you can change. So change the frequency, keep the starting voltage, and then for few measurements, then you change the starting voltage, and then again you change the frequency, and the table is filled up for 3 sets of the 0 volt, 5 volt, and 10 volt starting frequency. So I'm gonna run it with the 5 hertz, and you can read the current and voltage. I'm gonna change the range so we do a proper measurement. So for 5 volt, now I'm gonna go up to 10 hertz. Sorry, the previous one was for 5 hertz, not 5 volt. That was 10 hertz. Now 20 hertz. I have to increase the range. Now I'm going to 30 hertz. You can read the voltage and current for the winding. Now going up to 40 hertz. Going up to 50 hertz. And we just keep it to 50 hertz. We do not fill up more than 50 hertz. So just do the table for 50 hertz. Then I'm going to turn the power, go back to 5 hertz, and I'm going to change the starting voltage to 5 volt to go to the second column of the table. Again, you can read the voltage and current for the first winding. 10 volt, sorry, 10 hertz. Twenty hertz. Going up to 30 hertz. Going to 40 hertz. 50 hertz. Again, we keep it at 50 hertz and we do not go more than that. So now again, changing the starting voltage to 10 volt for the third column of the table, going back to 5 hertz and turning on the motor so you can read the voltage and current, and you can see the motor is running much faster. 10 hertz. 20 hertz. 30 hertz. 40 hertz. And finally 50 hertz. So that's all what we need for these 3 columns up to 50 hertz, and then you have to graph it using Excel or any other program to be able to answer the questions.
Next experiment is reversing the rotation direction. So I have set up the rotor, the whole motor in a Y connection, and then we are going to run the motor. I have set up again the line marker, so pay attention to the line marker to see the direction, if it is clockwise or counterclockwise. I'm using a motor control unit that goes from 0 to 50 with the ramp speed of 15. So I'm going to run it. Again, pay attention to the speed of the motor to be clockwise or counterclockwise, the rotation direction. And for the next part, I'm going to change the direction of the rotation. For this one, I'm removing these two jumpers that are connecting two windings, the red one and the black windings. Uh, they were connecting it to L1 and L2, so I'm gonna just cross wire them. So instead of connecting the second winding to L2 and the third one to L3, now I am just connecting them in opposite way. So I removed the jumper, which was a one-to-one connection, and I'm using two wires to cross wire them to connect, to switch the windings. And then I'm gonna again pay attention to the marker, and I'm gonna run it again and see where the direction is, clockwise or counterclockwise. If you didn't realize, you can just go back and forth to the video to see the direction if it changed or not. Next experiment is about temperature measurement for different currents. So we are applying different voltages to the stator, and then we try to see how much the temperature of the motor is going to change. LabSoft has a temperature unit measurement, so we can just use that one to measure the temperature. So at the beginning, I'm gonna apply the 6 volt with 1 hertz, and you see the motor started rotating like very slowly, and the temperature is read at 35 degree centigrade. I let the motor to cool down a little bit. For the next part, I'm going to go to the higher frequency for I guess it was yeah, 40 volt and 10 hertz. So I'm gonna set it up to 10 hertz and this one to 14 volt. And of course you can see that the speed is going high and high, and the voltage starts to go up. We have to let it run for a while to warm up. And when you don't see any temperature increase, it means that it's a steady state for data speed. So just keep going up. I'm gonna pause the video here and let it to get completely warm. So I let it run for like more than 30-40 seconds, and it seems that it's almost stable here at 56 degree centigrade. So you can answer the question based on the values. It's still going a little bit up, but considering around 57, 58.